I'm going to hand it over to Jackie and Peter, who's going to share with us bitter lessons of AI as they apply to SOC. Can't wait to hear what they have to say. Thank you so much. Jackie and Peter, take it away, please.
Yeah. Thank you. Hello, B-Sides, day 2, post-lunch. I hope you all are nice and full, and you're gonna bring that, just like post-lunch comfy movie theater energy for our talk. So we're really excited to talk to you about what we've been learning building AI-assisted detection and response, investigation and triage systems, both powered by and designed with AI. And as introductions, I gotta remember not to step back. I'm Jackie Bowe.
I'm Peter Sanford.
And we're also presenting on behalf of our colleague Jack Adamson, and we are the detection platform engineering team at Anthropic. Oh, and I'd be remiss not to mention Claude. Claude has really become one of our collaborators, one of our coworkers on this project, so we do need to give him his fair shake. So what is the current state? For any of us who have been working in threat detection and response, it's pretty similar to how it's been for the past 15, 20 years. We have too many alerts, too many signals, too many logs, and we're just inundated with false positives, or we're overtuned and we're missing things, and there's just not enough human eyes to actually look at all of these things. And as human analysts, we are tireable, fallible, and we don't really get offered a lot of great tooling options. There's a lot of great tooling out there, but for things that actually fit perfectly our use cases, we find that it's still lacking.
I would guess that some people in this room are feeling pretty skeptical about AI, and that's great. I personally have an aversion to security products touting machine learning features. And it sounds crazy that that's the case, but why do I feel that way? It's because I've been burned by black box ML, where the models work in the vendor's test environments, and they are great demos. They have great demos, but when I actually apply them in my environment, they fall over. And the reason that they fall over is that my data doesn't match what the vendor built their model with. And I asked the vendor about this, and they tell me, well, we don't know, but if you give us a bunch of samples, we'll try to incorporate that into our next training run, and maybe it'll get better over time. It's so incredibly frustrating, and we want to build something that is not that. It's easy to swing the other direction, though, towards a SOAR mindset, where we think that maybe we can just codify every possible investigation and response action, and that should be good enough to help us with the burden of more and more alerts.
And I mean, it is true that SOAR and automating playbooks can save you time and has been helping analysts out, but when we get into this headspace of, oh, we just need to codify exactly what a human would do in every situation, we fall prey to kind of oversimplifying the process and missing what a lot of the greatness of human investigation brings, which is creativity. It's trying things that haven't been tried before. And in this world of security orchestration, automation, and response, we aren't really given this freedom of creativity or this way to try a lot of different paths out.
Exactly. I think SOAR is so great when you have already seen a thing in your environment, but it doesn't help when it's a complete new type of attack that you've never seen before. This reminds us of an AI concept called the bitter lesson. The bitter lesson is the idea that trying to encode what we think of as human-specific thought patterns into models ends up being worse than training models generally. The big takeaway from the bitter lesson is that general methods and throwing compute at the problem win out against clever algorithms and encoding human reasoning into models. So some examples of this are training AI models to play games. Early on, game engines would try to encode human strategy into how the engines played games, and that worked okay. But those engines could not beat later models designed where there was no strategy encoded into the engines at all. And the models were built by just training them to play against themselves with different variations and to learn for themselves what strategies worked well and what didn't. And those models came up with new strategies that no humans had ever tried and were significantly better than anything that had come before them.
So Peter, are you saying that if we let the models cook, we get better results?
That is what I'm saying, Jackie.
Let them cook. So I actually stole this directly from Anthropic's documentation when we released 3.7, extended thinking. So the quote goes, "The model's creativity in approaching problems may exceed a human's ability to prescribe the optimal thinking process." And I remember coming across this as we were having these discussions about the bitter lesson and realizing that we are in this world where we're seeing the direct implications of the bitter lesson on a much larger scale.
We want to take a little step back and say that we are practitioners. We're not full-time AI researchers. So we've really been coming at this idea from the perspective of how can we start using the learnings of the bitter lesson in our day-to-day work while continuing to do our full-time jobs of keeping our companies safe. The good news is that it's really easier than ever to start trying these techniques out. We're going to walk you through the tools that we built to improve our detection investigation process as we continue to do operational work using just a very small team of engineers and really leveraging Claude to help us with that process.
Yeah, and so we're going to go over some of these foundational building blocks that went into building the systems that we're going to talk about. We're going to go through these relatively quickly because we want to leave time to actually show you some demos of what we've built and also, of course, take your questions. I think it's worth noting that we worked on this system as well as doing our core detection and response work for around just over 3 months, I would say. And we have built the prototypes that you're going to see today. So first, previously, we were kind of blocked on needing a purpose-built model to do detection and response. If you just tried to use a foundation model to triage alerts, you may get some results, but they wouldn't really be that great. But what we have found, especially within, I would say, the past 6 months, because things in AI move really quickly, we have found that the foundation models themselves are pretty good at this work, completely out of the box. So if you were thinking that you were blocked on having to do RL, like have a huge corpus of data samples that are labeled and then run an RL environment over it, we're here to tell you you don't need to do that. Yes, you could probably see optimization and performance gains if you had that time and that expertise, but you can really just use a model right out of the box right now. Also, we have found that one of the biggest things that sets you up for success in this paradigm is having a technical stack that supports integration with AI tooling. And so, the beautiful thing that we all wish is that we could be dropped into a company with a complete empty slate and unlimited resources and build from scratch the detection system that we would like. But we know that's not usually the case. But with tooling that you have and tooling that as you're looking to integrate new tooling, things to look for are tools that use common languages and frameworks. So languages for writing detections for your infrastructure. Python is great. We know that the models, especially Claude, is pretty good at writing Python. SQL as a query language is very well known, as well as Sigma for detection rules. There's so many Sigma rules out there that the more there is on the available on the internet about these systems, the better the model will be at using them. The other components that are really helpful are robust documentation, always, as well as APIs that make speaking to and working with a system very easy. Things to steer away from, and I'm looking at a lot of the legacy SIM providers here, are tools that treat how they work as a proprietary secret. If you are working with tooling that does not expose external APIs, that forces you just to work in a UI, you're gonna have a lot harder time, and you'll probably be boxed into using whatever model they're packaging and selling with their product, which again goes back to that black box ML theory that we were talking about, which we just really don't like.
We relied heavily on models to be our co-engineers with us throughout this process. They helped us brainstorm, prototype, and ship our systems. So starting by talking about how we did that, we really leveraged, we started with our coding process by leveraging a coding assistant. There's a lot on the market. It seems like there's new ones coming out every week. We use Claude Code for our development, but we expect that you would have similar results with many of the tools available. I have been personally excited about how people outside of Anthropic have been using Claude Code. I am a big Steve Yegi fan, and so my heart grew when I saw this post from Steve Yegi talking about the relentless nature of Claude Code working to solve any task that you give it. It just doesn't rest until it solved the problem you've handed it. So we're going to look at a quick demo of using Claude Code to prototype a UI feature for our investigation tool. On the left-hand side, you'll see the UI running locally on my laptop. On the right-hand side is Claude Code. I've opened Claude Code in the project. I haven't given it any information. I give it a really bad instruction of just in this investigation UI, I would like the ability to see raw transcripts without any additional context. It doesn't know anything about this code base, and it does a pretty good job. So we'll take a look at that. So on the right-hand side, you can see Claude Code and that request to, in the investigation UI, show, add a button to show the raw transcripts. Claude Code first starts by searching through the code base to understand what the code actually does, tries to find the investigation UI components. It then comes up with an action plan of how it's going to implement this feature, which it has those little checkboxes there. It's going to start editing the code, and the first edit, it asks for permission to make the change, which I approve and say, go ahead and make all future changes. As it makes the changes, the UI reloads automatically to reflect the changes. In a moment here, we're going to see where it actually adds the button to show these raw transcripts. The idea with this feature is sometimes it's useful to see all the specific details and not the summaries that are displayed in the UI. So that's the thing that we want to see. So it's added the button up at the top. It's now implementing the actions for what actually happens when you click the button. And in a moment here, okay, it's done. We'll go ahead and try clicking that button, and we see the raw transcripts in JSON. And it really does speed up development for us. Like, I consider myself a pretty good engineer, maybe not a great UI engineer. I think I could, depending on my context, how much I've been working in the frameworks, like I could maybe implement this in 30 minutes or an hour. And that is the real time, 1 minute, 30 seconds it takes for Claude Code to implement these features. So it really just speeds up our ability to try things out. And this was a really important part of us building this in such a short period of time. We've also been using tools and MCP servers a lot in our day-to-day work. MCP is the Model Context Protocol. And we're really excited about these as well. Tools are just a great way to break the model out of its constrained context window and give it the ability to interact with the outside world and also to do things that it may not be great at. Models, we know, will produce non-deterministic output, and if there's specific things where you need determinism, giving a tool that performs those actions can help get consistent results. And MCP servers are very exciting. We're seeing so hot right now. We're seeing more open source MCP servers every day. I think we were personally excited about Slack, GitHub, SemGrep, and the recent unofficial Ghidra and MCP server just released a few weeks ago. I don't know, Jackie, do you have opinions about that Ghidra server?
I contain 2 wolves, and one of those wolves is super excited that you can have Claude do reverse engineering for you, but also as someone who started my career reverse engineering and had to walk uphill both ways for my IDA Pro license, I'm a little salty.
The final component that we've been leveraging that maybe is talked about a little bit less is external memory. And this is the idea of like giving a place for the model to write down information and then make that available to the model later. This is surprisingly effective as another data source that our investigation tool can use to query in the future. You can basically think of it as a meta signal that the model can use in investigations. We're going to talk about this more in a few slides.
So putting all of these foundational concepts together, we are going to talk to you about how we use these at Anthropic to build the systems. Right, so while we mentioned that doing this first initial prototype of this system that we're using internally right now took us around like just over 3 months, the idea of building something like this has been percolating for a while. And so when we started talking about this, we found ourselves in the state that I kind of hinted at the beginning of this presentation, where we start out with a lot of firing detections. We're adding more every day. And then we have what we call non-firing detections, or like low confidence signals that are still important and many times can actually lead in aggregate to things like incidents or significant misconfigurations that we want to know about. But we don't have enough time to look at all of these, especially since non-firing detections can be around 100 times more in volume than our alerting detections. So we also knew, Claude doesn't really get tired. He doesn't really cut corners. We can spin up as many Claudes as we want, but we don't want to give the entire process completely over to Claude at this moment because, again, we're trying to avoid this black box of like we throw data in and data comes out and we don't know how we got it. So we wanted to create a system where we are collaborators and we work together on triaging detections. And while Claude does not cut corners, I will say we have found he can sometimes be pretty spicy in his deliberations, and we'll talk about that a little bit more too. And so, what did we do? Kind of what we do a lot when we have thoughts at Anthropic. We talk to Claude, and so Jack on my team had this conversation with Claude where he said, "Okay, here are all these concepts that we've been talking about." Write a white paper that in a year we have completely changed the landscape of detection and response. And we've done it by using LLMs. We've used humans in the loop. We've created this like collaborative triage platform. We've used external knowledge bases. And so this was the part of the prompt that we fed to Claude, and Claude ever so helpfully spit out a 48-page white paper. So helpful. And this white paper actually has some pretty good affirmations of some of the topics we were thinking about, and also some fluff. I mean, it is a 48-page white paper. So what we did from here is we distilled out the pieces that we wanted to include in our first batch of implementation. We distilled those into a design document, again, using Claude. We saved it in a markdown format. And then we dropped it into the repository where we're actually building these systems. And so with the design doc, we collaboratively worked with Claude Code, and Claude Code would implement a feature, we'd look it over, it would commit it, and then it would diligently go back and check off what it had done. And so we had, a clear trail. So it's vibe coding, but just in the sense that it's enjoyable, not in the sense that we're YOLOing it.
So let's dive into our process for building an AI-assisted investigation platform. We built this tool called Clue. Clue is a backronym for Claude Links Useful Evidence. I think Claude helped us come up with that backronym. But the initial idea for Clue was very simple. It was, let's take some detections and hand them to Claude and ask it, how would you investigate this detection? We would also ask it, what tools would you like to use to investigate this detection? We would then allow Claude to hallucinate what tools it wants, and then we would take those list of tools and we would ask Claude, please implement these in Python, and we would give it some information about our environment, for what is available, what APIs are available. Claude would go and implement that code in Python. We could look at it and verify that it's doing what we actually expect, and then we would plug that code back into this tool to complete the investigation process, where Claude would then actually call the functions that it wished existed and generate a final triage report for us. So you might be saying, aren't hallucinations bad? And obviously, we don't want Claude to hallucinate events that didn't happen. But we do want Claude to be creative, to let Claude cook, as Jackie said earlier. And so using some structured hallucinations is actually a strategy to get Claude to creatively solve problems we give it. For phase 2, we built on this early idea, and we added a bunch more features to automate things that we were doing manually. So we gave it more tools for searching both our SIM and externally other systems. We built a batch detection processing pipeline. We built an open-ended investigation UI where we can collaborate with Claude and use natural language to do investigations. And we built a storage engine for memory and also for storing artifacts and reports. I'm going to show you a very simple architecture diagram that Claude helped us generate this diagram. The point of this is that there's not that much to our system. We have a storage layer, we have an event bus and a queue for processing detections. We have a way for users to interact with the system and a way to pipe events into the system. But it's not very complicated. It is something that you can build with off-the-shelf services from your cloud service provider very easily. Don't be intimidated by a little bit of infrastructure. We're now going to look a little bit at the prompts that we're using. The main point of this is that there's nothing special, no secret sauce in our prompts. We're giving it like very general information. We've tuned these prompts a little bit, mostly by when things go wrong and Claude makes a mistake. We ask the model, what could I have asked differently? How could I have asked this question differently to have helped you answer correctly? And that's helped us to tune our prompts a little bit, but they're pretty straightforward, pretty simple. And we're going to look at the different components that are listed on this slide. So this is our alert investigation prompt, or the initial component of it. That we give it a little bit of instruction at the top, just some context for what we're trying to do. We give it the specific event that we're investigating. We give it the rule that triggered the event. We give it a set of SQL tables that Clue can query, especially when it's looking for additional data sources and for it to be able to expand out and do broader investigations. And then we give it some basic guidance for how to investigate and things to try and things to avoid. The main point here is that we've played around with like what works and what doesn't, and we want to give it like some constraints for how far it's going to go, but we don't want to be overly prescriptive about what it should do.
Yeah, and digging a little bit more into the tools that we built. These are all tools that we built internally, and they're pretty basic as well. Like the most important one I'd say here is Query, and Query just is a tool that Claude can use to query our data lake. So this tool has advice on how to do like optimal search queries and how to just interact with our data lake. As well, we, as Peter mentioned, like models are non-deterministic, and so sometimes they need a little help if you want repeatable results. So we have tools for creating reports because we want our reports to be structured and contain the same information. We also have tools for interacting with thinking, so extended thinking. So one of the interesting things that we do is we kind of create this conversational model where, if you just one-shot prompt Claude, you'll get a response, but if you ask it to think and kind of come up with a multi-step answer, you can get better results. And it can also use different tools in each stage of this conversation.
And here's the output of the investigation process. So Clue generates a triage report. It has its initial findings, and then just enough information for a human, if they're looking at this, to understand the key components of the investigation, and if they want to dig in further, that information is readily available. Another really important piece of this tool is every investigation has a full investigation transcript. This means that we can verify everything that happened. Everything that Clue did is in this transcript. We can go see its thinking process. We can see what data source it accessed. We can see what queries it ran. It's really helpful if there's any question about accuracy, and it's also helpful as we tune the tool and try to make it better. This is a lot of where we think we have something that is different than the black box ML that we talked about at the beginning, where we can have actual confidence in the process and in understand what the tool is doing.
Yeah, and one of the things that we also find really turbocharges the model is having context, and that's organizational context about things that it's done in the past. So we store every investigation report and every printed detection report into a repo. And we mentioned earlier, these knowledge bases don't need to be overly complex. You don't need to use RAG or a semantic graph to start out with. Obviously, those are great, but you can just use a bucket. We just use a bucket with a file structure that then Claude has a tool to understand where things are stored, where the metadata is, and it can interact with these reports quite easily. And so this is where we get into kind of the stuff that I'm very excited about. So batch processing. So our idea was it's great to generate singular reports, but we would love to see patterns over time. And going back to talking about two different kinds of detections, you have your alerting detections in red. And these are detections where you know that humans should look at these. There's some kind of, they're really high confidence. Each of those gets their own report generated. But then we have, on the order of 100x number of signals, which are lower confidence detections. And for each of those, they all kind of get batched together. And for the report and the summary functions, these are workflows that each have their own tools and their own schedule. And so the summary report runs over a batch of these lower confidence signals. And from that, we do what we call meta-analysis, which is another workflow, which includes prompts and tools that gives you a summary kind of your environment. And the thing that we're really excited about here is that not only are we in control of every component of this, we can spin up tens, of different experiments, trying different ways to write reports, to write summaries, to do meta-analysis. We can do best of n in, running the same detection through the model and getting n different results and comparing them. This is very exciting because something that I have been sold, again, for, over a decade is UEBA, or User Entity Behavior Analysis. So it's this idea that if you can fully understand what's going on with your users and your systems, you can quite easily see anomalies. And what we're building here and what we are excited to build in the future is something where you can do this entity extraction and get a really close contextual idea of what's going on in your environment, and you don't need external tools for it. And yes, this is another demo. And this demo, as we mentioned, we built an investigative UI. And we didn't set out to build this, but we found that once we gave Claude and Clue the tool use and the other features that we gave it, suddenly it was very, very good at being a collaborator in doing natural language investigations. That's me. That was interesting. It was Inception. Okay, so in this demo, we're going to go through a investigation where we have a situation where we have a set of contractors and we have some concern that they may have had access to systems and documents that they shouldn't have. So we want to, this is, a classic problem in investigation or incident response. Can someone go and look through the logs? Ta-da! I know. The demo gods say no.
Even to a video.
Even to a video, I know. Okay. I don't know, did we? Okay, sweet. Yay! Huzzah. Yes, please. Cool. So we're actually going to try to slow this down because the investigation engine is too fast to actually explain what's going on here. So we've asked our natural language question of, here's the name of 3 contractors. Can you get me the logs to show if they have access to anything that they shouldn't have? We have a concept of, FTE clearance as well as contractor clearance. You can see the conversation here. So the only thing that is on the analyst side was the first query that was kicked off. And now you see this kind of conversational flow of Claude going through and making queries into different tables in our data lake, gathering the results, sometimes makes like a SQL error like we all do, and then it will correct itself. And so the nice thing about this is you can issue an investigation query and continue on your day and come back. This took just about 2.5 minutes to run. And at the end, we get a full report about what Claude has found. And the nicest thing is you can go back up and see what queries were run. So if you have any question on how did we get to this verdict or where is this information coming from, we have the full logs. Yep. And I talked a little bit about things we're excited about that we're going to build onto this. Like I said, we're still very early in this prototyping stage. We talked a lot about how to apply this work to response. So we talked about investigations, we talked about alert triage, but especially if you are using CI/CD for your detection rules, you can actually have Claude make suggestions to tune your rules, to write new rules. Also, kind of I talked a little bit about the white whale of UEBA and having a clear idea of what is going on in your environment that is generated for you. And kind of, again, one of these beautiful goals of a functioning detection program should feed back into preventative controls. So every time you have an incident or something happens, you should be feeding back into maturing your preventative controls. And we do believe that in the future, a system like this could assist in both suggesting and potentially creating patches for preventative controls.
And finally, we just want to really encourage you to start experimenting with the same techniques that we used. As we said earlier, we are a very small team. We did this kind of on the side from doing our normal detection and response work. We could not have done this in the time that we did or our team size if we didn't have tools like Claude Code available to us. But the key thing for us is just those gave us the ability to prototype and to try things and to get that rapid development cycle going. And the more that we did it, the more excited we got about it, and the more fun it was to build more things into this platform. Yeah. So you should just start experimenting, start prototyping, see what you can build. Don't try to add everything at once. to start small and build from there. All right, we have questions.
Well, thank you very much. Again, that was great presentation, a lot of insights. And we have questions pouring in. So
Great.
Great, love
so
that,
nice
thank
that,
you.
there is a few minutes left. And I will try my best to squeeze as many questions as possible in. The rest, you guys will have to take it up with the
Catch us outside.
fantastic presenters upstairs. If you buy them a drink, they'll probably answer your question. All right, let's get going. This is one interesting one. How much would your project have cost if you were a customer?
Yeah, that's a great question. So one of the fun things about Claude Code is we can benchmark how much queries cost. And so we have some rough ideas about per alert. It can range anywhere from 20 cents to like $1 per alert, which obviously, is something that we are working to pare down. And then with the summary analysis where you have like hundreds of alerts into one summary, again, it's like, 50 cents to $1. And that doesn't count the cost of like the data lake or, so.
Yeah. And I think the thing that we're seeing is just the economics of LLMs is they continue to get smarter, and smaller models continue to be more affordable and be comparable to larger models from just 6 months ago. So we expect the cost of this to go down significantly in just a fairly short period of time.
Thank you very much. Another one here is, what do you mean by structured hallucinations?
What do you mean? What we mean by structured hallucination is we talked about tool use, and tool use is a great way to kind of coax a model down a path. But when we talk about hallucination, we want the model not to be stuck in a rigid way of thinking. I keep hitting this. In a rigid way of thinking or on a prescribed path. So we want the model to be creative and to come up with ideas that we couldn't have come up with. And so that's where we elicit hallucination in like a structured format. So it's not like creating network flow logs, but it's, it'd be really great if I had a tool that did this.
Yeah, I think constrained hallucination is
Yeah.
really how we think about it.
Okay, thanks. Are you not concerned about auth-z issues with MCP?
I think a lot of people are concerned about that. There's significant work being done. I think we'll see improvement relatively soon. But also, I think nobody talks about like auth-z issues with LSP servers and how they integrate with development tools. And you have to understand what your MCP servers are doing. But I think we'll see good solutions for that relatively soon.
Thanks. Do you see Anthropic open sourcing these tools and workflows? If so, on what time horizon it might happen?
Yeah, that's a great question. I think we encourage you to try to build these things yourself because we do believe that with Claude Code, why is it? Oh. With like things like Claude Code, it's really, really easy to prototype. So coming up with kind of the process we talked about where you have a design document, you can drop that into what you're building. But we are thinking about open sourcing because what we've built can be CSP agnostic. You can, use whichever CSP you want. We're using kind of foundational building blocks that are available across CSPs, whether you use GCP, AWS, or I'm sorry if you use Azure. Sorry. I told you I wasn't going to be spicy. And also SIM agnostic. So we believe that, however you are querying, wherever your data is, this tooling can be agnostic from that.
Yeah, there's a large chunk that's just glue code that is specific for our different databases and our environment. And so that's why we don't feel like we're ready to release something right now.
Yeah.
But there's a lot that like potentially we could share.
Okay, I'll try to manage this microphone. How do you think the next version of Claude will further amplify this workflow?
Yeah, I think what we kind of have, we were just talking about this, weren't we? Or like forecasting that a lot of what we're doing is building with like our tool use, we're building all this scaffolding around the model, but we believe with time, the model itself is going to get better and better at doing these things itself. So we'll see kind of, right now there is the model and it's surrounded by an ecosystem of tools and integrations. But I mean, in my mind, we will kind of continue to see most of those capabilities start to become part of the core model itself.
Yeah, there's something that we're not doing yet, but we hope to do is use different models for different parts of the process. So smaller models that are less expensive are probably still very good at writing SQL queries. And we want to leverage things that a lot of the AI coding assistants are already doing, where you have the most intelligent model thinking high level about the plan for doing an investigation, and then delegating to less expensive, faster models for actually executing on that plan.
Yeah, that's a good point.
Great. The next one I'm reading out is, how are you auditing and monitoring clue activities similar to any enterprise applications?
I guess, is that how we're monitoring people using Clue? I think that is the way we monitor any of our hosted applications is we have audit logs and access logs, and that's how we monitor that. I think if we're talking about monitoring like the actions that Clue does, or like verifying that Clue isn't making mistakes, a lot of that comes down to looking at the audit logs if something doesn't feel right, if it feels like something was missed. And then just periodic, as we're building the tool, we're reviewing the audit logs quite a bit in understanding like where things are working and where things aren't. And so we're doing a lot of auditing there as well.
Do you retain Claude with new investigations or just rely on fresh context?
Yeah, that's a great question. The context window is clear every time we do an investigation, and the way that we access context is through tool use. So when we talk about our knowledge base, Claude has tools that it can reach and pull things into its context, but we can't start every conversation with context. And actually, we believe that this is a benefit because if you have already preceded the model with how it's been doing investigations in the past, the likelihood it's going to not try novel ways of investigating is higher. So having a clean context window is actually advantageous.
It is an interesting one, I think. In the Clue security audit of 3 users, will Claude respond nicely if you ask it to tweak specific investigation sections in plain language?
Not exactly sure
No?
what that's asking.
That we can take it offline. We can
Yeah,
pass on that.
apply
no
this
problem.
afterwards.
Yeah.
Great. You had a great access review demo. Were you able to automate this kind of activity completely?
By automate, again, I'm not quite sure what the question is, but we do, something that I'm currently working on is the capacity to do scheduled queries. So say, you have like a user who has been, has come to your attention of doing some things that maybe not be like by the book, and you want to just run kind of like activity reports. You can create scheduled queries that will run like these kind of natural language things over time. And then you can also use things like meta-analysis and summaries over that.
Well, I think that's most of the question. There are a few still left, but I'll let people approach you so that you can get some drinks out of them. Once again, folks, thunderous round of applause for our speaker, Jackie and Peter. Thank you so very much. Really appreciate it.